the marker over here. No. Did you turn that on?
Yeah.
Hello. Hello, austerity.
Who? Austerity.
Your marker.
Please explain.
What happened to the marker that we were using earlier?
Oh, there's one sitting right there.
Is there a fax and there's one right there?
There's one.
There's one right there.
There used to be two up
There's
here.
one right, it's right there.
Yeah, it's over here. Okay. All right. You can rewind that thing. Over here. Six. Yeah, this is a good one. All right, I got another one, but I'm just gonna get rid of this one. Where's my trash can?
Right there!
Oh, it's over here.
Wait, I got it.
Who put it over
I
here?
got it.
Did you put it over here?
No.
Wait, don't do it yet. Don't do it yet.
We're going for one day and things get rearranged in my room. All right, I'm through with this marker.
Yeah!
Did it go in?
It went in, yeah.
I got that whole
First
thing.
one of the year, you gotta make it.
I've always wanted to have that on video, and I finally do.
That's 1 for 1 for the year.
1 for 1.
I don't think I've done it before.
Ooh, on the shirts we should put like blank for blank. You know?
Yes, and now we've got to have. There's at least 1 for 1.
What unit goes here?
Moles.
We were spending a lot of time. We haven't gotten anywhere yet. What unit goes here?
Moles. No.
Could be. No, not moles.
Grams.
Take it back.
It's not right.
It could. There are two things it could be. One is grams.
Oh!
That many grams in 1 mole. And if that's the case, we call that the molar mass. Capital M for molar mass. Molar mass for lithium is 6.91, and that would be grams per mole. See, so the unit is the gram, and what it means is that many grams are in 1 mole. So grams per mole.
Wait, so that's a significant number, or did you just make that up?
No, that's this number right here for lithium.
Oh, okay.
6.9. Oh, it's 6.94. I copied it off the periodic table wrong. There you go. 6.94 grams per mole for lithium. Now, the other thing it could mean is the atomic mass unit. Do you remember that? It's symbolized by the lowercase u.
No.
It means atomic mass unit. Some textbooks would write AMU for atomic mass unit, but most books today just use the U. And it's atomic mass unit, but that's the mass in an atom. That's the mass of 1 atom. Whereas that many grams is the mass of lithium if you have 1 mole of lithium. That in atomic mass units is the mass of just 1 atom of lithium. So the atomic mass unit's a really, really small unit. See, it is a unit for mass. These are both units for mass, grams and U's. Neither one is the SI unit for mass. What's the SI unit for mass? The kilogram. In physics, we like to use SI units. And so you probably should know that 1.66 times 10 to the negative 27th U's is equal to 1 kilogram. That's just the conversion factor. And that will be on the equation page of the constant page of your equation sheet when you take the AP exam, if you ever need to convert. If you're getting a number off the periodic table, but you need kilograms, that's how you would convert. Okay. Now remember again, though, that's the mass of an atom. If you're trying to talk about a mole of lithium, then you've already got grams, and if you need kilograms, you just move the point over 3 places. See, that would be 0.00694 kilograms are in 1 mole of lithium. So grams and kilograms, you already know how to convert. But if you're dealing with an atom, and then that same number, but it's in U's, and if you need that to be kilograms, that's how you convert. So that's the first thing from this chapter. That's not a big thing. Chances are you'll take the entire AP physics exam and not need that, but you might. I don't know. I mean, it's possible. It will be on your equation sheet. All right, the next thing related to chemistry type things you might have learned 2 years ago is the mole itself. What is a mole? You might remember that 1 mole of any substance is Avogadro's number, which is 6 point, anybody remember it?
6-7.
Good guess, but no. 6.02 times 10 to the
-9?
23rd.
Yeah! What was the -9?
Can I sharpen my pencil?
That's the number of particles in 1 mole. I already put 1 mole equals. That's the number of particles that make up 1 mole of anything.
How do you measure a particle?
A particle would be what it's made of. It's made of atoms. Like if you have 1 mole of lithium, they would be atoms. If you have 1 mole of water, then the particles would be called molecules, but it's still that many particles.
Oh yeah.
That many particles, depending on what the substance is, what you call particles. But that many of them would be 1 mole. Do you need help with that? The 2 equations that I would remember, molar mass, we just talked about a minute ago, is the mass per mole, where little m, this means molar mass. Little m is the actual mass, and that's right there is in grams, and n is the number of moles. So if you know the number of grams and the mass, you can actually divide that and get the molar mass. But you're more likely to know the molar mass because you can look that up on the periodic table. Okay, but this is one thing that we talked about a minute ago. And then the thing we talked about right here is that Avogadro's number, which we symbolize that way, Avogadro's number, would always be equal to the number of particles. They use a capital N for number of particles with no subscript, it's just number of particles, and divided by the number of moles. Is that really true?
Wait, what is the NA?
Yeah. This is Avogadro's number, which you know, it's always the same. So if you're going to use this equation, the NA is the number you know. And so if you know either one of these, you can find the other. This again is the number of particles, like the actual number of atoms in something, and this would be the number of moles. So you're not likely to really know how many atoms are in something, so chances are this big N is what you don't know. You do know Avogadro's number, so if you know how many moles of a substance you have, you can use that to calculate how many molecules. If you say I've got 3 moles of water, you can actually calculate how many molecules that is for this. Okay, so these 2 equations are things that you're likely to need, perhaps even in some of the homework. Again, this is not a big deal in chapter 14, a much bigger deal coming up, but this is still some of this you may need to actually work the problems. You may need to know the number of moles in something, and what you know is these 2 things. You may know the mass and then the molar mass, and you can find the number of moles that way because you need the number of moles to do something else. So those kind of things can be helpful, so make sure you understand them. Avogadro's number would be on the constant page, so you don't have to remember it. And that conversion of use to kilograms, as I told you, that's on the constant page. So those are the old chemistry things you need to know, and I think that's all I'm going to say about that. We're going to move on to section 2, which is the ideal gas law. You have that in chemistry as well. Gases. The things you can measure about a gas are you can measure its pressure. P for pressure. We talked about pressure back in fluids. Remember pressure? You can measure the volume of a gas, how much space it takes up. You can measure the temperature of the gas. And so you might remember the ideal gas law as POV equals nert. Right. Where those three variables are here. P and V on the left, T's on the right. N and R. And little n again is number of moles, just like it has been in what we talked about a moment ago. N is the number of moles of the gas. R is the ideal gas constant. R is the ideal gas constant. And it is 8.31. Let's see, is it always going to be 8.31? It depends on the units, but the T will always have to be in kelvins. Let's get this in. That's got to be in kelvins. This is not a delta T, it's just a temperature. So you can't use Celsius here. This is the actual temperature in a scale that cannot go below 0. N, of course, is in moles. That is moles. V, the SI unit for volume, is cubic meters, and everything in physics uses SI units. So remember that, and we use that same equation in chemistry, but we use different units. However, in this class, everything's SI. So the volume has to be in cubic meters, and the pressure has to be in pascals. And I guess that's time to stop. Is that really time to stop on that?
It's learning all day.
We're supposed to have for 8:54. Aren't we on regular schedule? We're not. What's happening?
Learning lot.
What?
Wait, isn't it learning lot? Monday?
Probably.
No, Monday's supposed to be regular.